Okay, so this is this is my first test of gear cutting on the Boley lathe using this index driver that I made instead of a dividing head or index plate. So I just want to show you around here first of all. The index driver is basically a stepper motor that goes in line with the drawbar. And so you still have the handle on the drawbar here, and when it's disengaged, you can change your chucks or whatever, collets. And then it connects to a little controller, and the controller is just a Raspberry Pi, which is a small Linux computer in a box with a stepper motor controller and e-paper, like a Kindle screen, and then a numeric keypad to put in numbers, because we're going to tell it how many divisions we want to cut this gear. And I can see all my camera points of view on these screens, and so can you when I cut to them. So I think that's it. Oh, the other thing is, over here I have another lathe setup which has the same thing. This is a larger version. This is a geared version of the stepper motor index driver. This is another version of it I made. The display is not on right now because it's turned off. But basically this goes in line with this drawbar and allows you to do the same thing on this lathe. The cross slide can go there with the milling attachment, with the power for the milling attachment. And speaking of the power for the milling attachment, so this is running off the same motor I normally run my lathe with. I just put, for different milling operations, you need a different path for the belts. So in this version, because the milling attachment axis is horizontal, the rotation, you need the belt like this, and for other ones you go over the top and then it comes down if you're going to do a milling operation from the side or from the end. This is the control for the motor. And then, oh, there's one other thing I just want to show you. This is a micrometer, which the first thing I'm going to do is set this to cut the teeth about 1.5 millimeters deep. So I've already, and this measures in thousandths of a millimeter. So I've zeroed this thing out, or not zeroed, but I zeroed it at 1, which is what it's set at right now. And then when I go forward with the cross slide, it will go down. When it's 1 millimeter in, it'll go to 0. And then I can go another 1/10 of a millimeter, and then it stops. Okay, so anyway, I'll go like 110 deep. But I just wanted to show you, this is measuring in thousandths of a millimeter. And the interesting thing about this is that not only is it just, like right now it's just set up to measure how far forward my cross slide is. But if you, when you start doing real gears, like this is just a experiment, but when you start doing real gears, you want to be able to set your depth really carefully, but you also want to make sure that there's tolerances everywhere. So you can use a micrometer to measure tolerances at all these points. How much if the blade is in line, you know, the spindle of your lathe, the workpiece itself. You can see here, I've got, just visually, you can see that I've got a very concentric cut on the gear blank. And also, incidentally, this gear blank was super glued to this wax chuck and in my other lathe. And then I took it down to be perfectly concentric because it's hard to center it on the lathe. So I used the other lathe and the hand graver here with that same wax chuck in this lathe to bring it down to center. And that's something that's also interesting about having two lathes, which is like once you do a setup that's complicated, and you realize you need to do some other little bit of work, it's great to have a second lathe, or I can imagine a third or fourth or fifth lathe, all set up so that you can do different things on different lathes. Okay, so to start, we're going to move the milling attachment a little bit further this way, and then go into our end position, which is 1.1 millimeters. And then I should lock the cross slide, but it's pretty stiff right now, so I'm not going to do that. I have locked everything else. And then the stepper motor will lock the workpiece and the spindle. So I'm going to do the index driver now. Okay, so num lock. You can see that num lock is on from the LED there. And then we're going to enable num lock and press button B. Now it's going to, I'm going to enter the number of gear teeth. Don't need those glasses yet. I'm going to enter 28 gear teeth. Now there's that little reset, so if you have a geared transmission on the stepper motor, it takes out any backlash. But even without it, it's useful to have the motor engaged, because this motor's in microstepping mode, which means that it's got 200 positions per 360, but it's in 1/32 microstepping, which means it has 32 positions for each of those 200, for a total of, I think, 6,400. So when you turn it on, it finds 0, and then it kind of locks there. So now as we go forward, it's going to go forward in increments of 64,000th of a 360 per click or unit or whatever. And I can cut the first gear tooth. So I'm going to That's deeper than I thought, but we'll check it afterwards. Now I'm going to enter 1 to tell the indexer that I've cut the first tooth, and hit enter. Now it rotates to the second position. Two. Okay, I don't understand what's going on. 999. Okay, that was just a... Shit. Okay, so I have to follow through with this now that I did it. Don't know what to do about that. Doesn't seem like there's any terrible tension on it. Okay, press D. I want to start over. And then I'm going to enter 28 teeth again. There's our backlash. Make sure we're lined up with slot 1. Now I've got to successfully get to position 21 sequentially. So 1, 2, I'm going to make it so it's easier to see. Oh boy. Three. 4. 5. 20. 21. Okay. So, not perfect, but that was pretty good. I'm going to, just in case I want to go again for some reason, I'm going to enter 1 again. So when we do that, if we shut down the unit, then the stepper motor loses its basis or whatever, where it is. So if we do 1, it'll prompt us to go through the whole menu again. And that's how I kept it able to resume after failures. I think that the failure I had at tooth number 21 was actually just data entry. I didn't press the keys hard enough, and then I didn't pay attention. If you're paying attention, if you mistype the number, or if you don't press the key hard enough, it just will do nothing. But you just have to keep entering until you get the number right. And the reason for that is just so that you don't accidentally do something stupid. It's try to make you conscious of like doing the gears in numerical order and not get in the habit of like just typing enter and then getting confused and being like, oh, did I type enter or did I not? So maybe that I just should have tried again instead of cycling through the whole thing when I had the problem at gear 21. In any case, now what you could do is change the cutter to a gear shaping cutter. In theory, this could also go on the topping tool to follow these slots and to shape these teeth like gear teeth. But the other thing is, I've noticed some of the gear cutting wheels are like left side, right side. So you can see that like these teeth, because of the size and the depth, I think I cut them too deep, but they're not really for anything. So I just think I should have arbitrarily picked something less than 1.2 millimeters. But they're a little bit shaped like this. So you can imagine the cuts. You can imagine if you put gear teeth in it, you have to have the correct angle, not just like in theory, every gear tooth cutter would be unique to be perfect. So I think there are left and right cutters, or a cutter that you could flip. So you position it first, you do all the left sides, and you flip it and do all the right sides, and introduce the correct angle on each tooth. Now, I think on watch gears this small, there's something called micro teeth, which are just not as precise as real gear teeth on a larger gear, but the whole point of this is to try to do whatever's necessary at the highest tolerance possible. The teeth on the cutter look like they're still sharp. Now I don't really know what to do next. I feel like the proper demo of this would be to use a gear cutting wheel so that it doesn't look like this one. Oh, I know what it is. I need to figure out why, like on 26 or 27, it shifted. See, there's this much shift in the motor that's pretty easy. This is what's not ideal. Just because this is a little NEMA 17 motor, it just doesn't lock really well. I bought a little electromagnet lock. It's probably what, it probably should be like a lock you apply afterwards. Some of these motors have an optional lock. Also, this is loose because I have yet to get the perfect spacing and everything for this offset. But I think this is good enough. The other thing is on the other lathe, there's a gearbox, and the gearbox makes it much more precise, and it also kind of locks better. On that one, I'm using constant brake because the gearbox is so powerful it can overcome a brake. So I just have a brake on the back of the motor that's constantly braking it, meaning putting a lot of resistance. The motor has plenty of power to overcome that resistance, but in theory, a cutter going into the workpiece is not going to be enough to jolt it. This is the problem here. But that's accurate enough for these type of teeth. Not that I'm satisfied with that. I'm definitely looking for perfection. But the micro-stepping is working, and it's pretty good. Oh, I forgot to turn this light back on. I think that's it. I'll do another one. I'll do another one with a proper gear cutting tooth. All right. Today I'm going to cut my first gear, and the way I'm going to do it, I'm using a Boley 8mm lathe, milling attachment, and a CNC Index Driver that I made. And the Index Driver takes the place of a dividing head or index plate, and it revolves the workpiece a few degrees for each turn for you to cut the gears. And the thing I made is the stepper motor controller, which is a Raspberry Pi with a stepper motor driver and an e-paper display. And yeah, and it rotates the motor to 28 different positions. And by the way, this is on my website, imakewatches.com. The whole project only requires $125 US worth of parts to make the index driver. Sorry, not the lathe and everything else. But if you want to make gears, one of the most complicated things, particularly on a small lathe or expensive and complicated, is the indexing. And if you happen to be making a gear with the number of teeth that's divisible by the number of index points on your lathe, and if you happen to have a pin for it, you can make a certain number of gears that way. But the index driver allows you to make any number of gears from 1, which is impossible, to 360, like 1 every degree, which is also kind of impossible. But that's that. And now to use this, I spent quite a while on the software. The software is also all on the website for this project, the CNC Index Driver on imakewatches.com. And you can read the Python script that I wrote that does all this stuff. And it's a great way to learn Python as well, if you're interested in that. All the code is on the webpage and annotated, and then you can download it, and there's all the instructions to just buy your own parts and make this yourself. So the first thing it does, boots up like this. To start the process, enable numlock on the keypad and press button B on this unit. Enter the number of gear teeth, wait for the backlash reset, and then wait for display prompts. So when I put in the gear teeth, I'll put in 28, and then you'll see the motor move, taking up any backlash in the gear train, if there was a gear train. Okay, and then the indexer says 28 gear teeth calculated, 12.857 degrees per tooth. You may now cut gear slot 1. When finished, enter 1 or 989 to return to 0 position. So the normal progression is after each gear you press whatever gear number it was, and that's just to kind of keep you from spacing out, and just hitting enter or something can be confusing. So I'm going to put down the iPhone now and just go through this step by step. So I've already done my best to position the milling attachment on the cross slide, and I'm ready to cut gear slot 1, so I need to put power to it and see how it goes. Okay. That was almost there. Damn it. All right. That's why, you know, I kind of knew I had to tighten that more, and I forgot. So, so close, and yet back to the drawing board. No, this is kind of what I would expect. It's not easy. It takes a while. That's what's so fun about it. All right, thanks for watching.